Hello, friend. I am Neil Tyson, and tonight I will be your guide on a journey beyond our solar system, into the quiet depths of the Milky Way. Come, settle in. Let the weight of the day drift away like a feather on a gentle breeze. Allow your body to grow heavy, your mind to become still, and your breath to flow as softly and steadily as the turning of the earth. We are about to embark on a voyage not of speed, but of immense time and distance. Our destination is a question, a whisper carried on the solar wind. Have we been visited? Has our small blue world, in its patient orbit around a single star, ever been touched by messengers from other suns? Imagine, if you will, the space between the stars. It is not empty. It is a vast, silent ocean, filled with countless islands of light we call galaxies. Our own island, the Milky Way, is a swirling city of hundreds of billions of stars. And like any great city, it is full of travelers. Comets, asteroids, and particles of dust are constantly moving, cast out from their home systems by the gentle gravitational nudge of a passing star, or the final, powerful exhalation of a dying one. For eons, these wanderers drift through the velvet darkness, silent pilgrims on journeys that span millennia. They are cosmic mail, letters written in elements forged in the hearts of stars we have never seen, sent without a destination, simply outward. They travel through gulfs of space so cold and so quiet that our busiest thoughts would seem like a raging storm. They move for ages, past swirling nebulae where new stars are being born, past the solitary gleam of white dwarfs, the lonely embers of suns long past. These travelers carry with them the chemical signature of their birthplace, a quiet story of their own solar system. And so we lie back on our own peaceful shore of this cosmic ocean, and we wonder. We look up at the tapestry of night, at the diamond dust of the Milky Way splashed across the sky, and we ask, has any of that stardust mail, after its impossibly long journey, ever landed here? Have any of these whispers from distant suns finally found a home, however briefly, on Earth? Let your mind relax as we ponder this question. There is no need for an immediate answer. The joy is in the journey, in the gentle unfolding of the mystery. Breathe in and let the universe in. Breathe out and let go of all that holds you. Tonight, we will listen for the echoes of these ancient arrivals, and perhaps find a deeper connection to the cosmos that cradles us as we sleep. To begin our journey, we must first learn the language of these cosmic arrivals. The words themselves are soft and gentle, each describing a different phase of a wondrous transformation. Imagine a small traveler, a tiny rock or a particle of dust drifting through the cold, quiet emptiness between the stars. As long as it is out there, in the silent sea of space, we call it a meteoroid. It is a wanderer, a solitary speck on an immense journey. It is a promise, a potential message waiting to be delivered. Now, imagine this meteoroid's path, after millions, perhaps billions of years, finally intersects with our own small blue world. As it is drawn in by Earth's gentle gravity, it encounters our atmosphere, our planet's protective, invisible veil. Suddenly, its journey of silence is over. It awakens. The friction of the air, even miles above the surface, causes it to incandesce, to burn with a brilliant, fleeting light. This beautiful, momentary streak across the night sky, this is a meteor. It is often called a shooting star, a fitting name for something that has traveled so far to give one final luminous performance. It is the meteoroid announcing its arrival, writing its signature in light upon the canvas of the night. And if a small piece of this traveler survives that fiery passage, if it completes its journey and comes to rest upon the Earth's surface, its name changes one last time. It becomes a meteorite. It is no longer a promise or a performance, but a physical message, a tangible piece of another world that you could, if you were so lucky, hold in your hand. Meteoroid, the traveler. Meteor, the arrival. Meteorite, the message delivered. But tonight we are listening for a very special kind of message, one that has traveled not just from within our own solar family of planets and asteroids, but from much, much farther away. We are listening for whispers that are truly interstellar. What makes a visitor interstellar? The answer lies in its story, written in the language of physics. Everything in our solar system, from the mightiest planet Jupiter to the tiniest grain of dust, is bound by the gravity of our Sun. They are all part of the same cosmic family, orbiting together in a predictable, elegant dance. Their paths are closed loops, ellipses that bring them around and around again. An interstellar object, however, is a true outsider. It is not part of our family. It is just passing through. It was born in another star system, orbiting another sun. Some ancient gravitational event, a cosmic nudge, sent it on its way, breaking it free from its home star's embrace. It has traveled through the deep, open space between the stars, a journey of unimaginable length. When it enters our solar system, it is not captured by our sun's gravity. It is moving too fast, carrying too much energy from its long voyage. Its trajectory is not a closed loop, but an open curve, a path we call hyperbolic. It comes in, swings past our sun, and then, if it does not happen to collide with a planet like Earth, it continues on its way, back into the interstellar void, never to return. So, how do we, from our quiet perch on Earth, recognize such a traveler? How can scientists tell if a fleeting streak of light was a visitor from our own neighborhood or a messenger from a distant star? They listen to the story it tells with its speed. An object from our own solar system can only move so fast when it reaches us, its velocity limited by the pull of our sun. But an interstellar object arrives already moving at a high speed relative to our sun, a residual velocity from its journey through the galaxy. When it falls toward our sun, it accelerates even more. By measuring the speed of a meteor as it enters our atmosphere, astronomers can calculate its trajectory, rewinding its path back out into space. If that speed is so high that the sun's gravity could never have held it in a closed orbit, then they know. They have witnessed the arrival of an interstellar visitor. It is a cosmic fingerprint, an undeniable signature that says, "I am not from here." It is the universe quietly revealing its vast, interconnected nature, one fleeting, fiery messenger at a time. Let your mind drift on this concept, the idea of a cosmic speed limit for local travelers and the thrilling velocity of those who come from afar. It is a gentle, cosmic law that helps us distinguish a neighbor from a guest from a truly distant land. And now, my friend, let us travel back in time to a quiet night on our planet. The date is January 8th, 2014. The world is turning, most of its inhabitants asleep or going about their lives, unaware of the silent dramas unfolding in the sky above. Over the vast, dark expanse of the Pacific Ocean, near the shores of Papua New Guinea, a tiny messenger completes its journey. It is no bigger than a piece of fruit, perhaps, yet it carries a story billions of years old. This little meteoroid, catalogued as CNEOS 2014-08, enters Earth's atmosphere at a staggering speed, over 130,000 miles per hour. For a brilliant moment, it becomes a meteor, a silent firework in the pre-dawn sky, a flash of light seen only by satellites and recorded as a tiny, anonymous blip in a government database of such events. And then it was gone. Its fragments, if any survived, sprinkled down into the deep, dark water below. For years, this event remained a quiet secret, a single line of data among millions. But the universe has a patient way of revealing its wonders. A few years later, two astronomers at Harvard University, a young, brilliant student named Amir Siraj and his mentor, the renowned astrophysicist Avi Loeb, were on a quest. They were sifting through this public database looking for outliers, for meteors that told a different story. They were searching for the cosmic fingerprints of interstellar visitors. Patiently, they analyzed the data, calculating the speeds and trajectories of countless fireballs. And then they found it, the little meteor from 2014. Its velocity was extraordinary. It was far, far too fast to be a part of our solar system. When they traced its path backward, out beyond the pull of Earth, beyond the pull of the Sun, they found that it was still moving at an incredible speed through the galaxy. Its trajectory was not an ellipse, but a wide, open hyperbola. This tiny flash of light over the Pacific had been an interstellar traveler. They had found what they were looking for. Amir Siraj and Avi Loeb wrote a paper announcing their discovery. They proposed that this meteor, which they would later nickname IM-1 for Interstellar Meteor 1, was the very first object from another star system ever detected arriving at Earth. At first, the scientific world was quiet. The discovery was astounding, but the data used to calculate the meteor's speed came from a classified network of government satellites. The exact measurements, the error bars, the precise details needed for full confirmation were not public. The paper remained unpublished, a tantalizing possibility waiting in the wings. It was a whisper of a discovery, not yet a clear announcement. But the two astronomers were persistent. For years, they worked to get the data declassified and their findings officially verified. They believed in the story that the numbers told. And then, in 2022, the confirmation came. The U.S. Space Command, after reviewing the classified data, issued a formal memorandum. They confirmed with a high degree of confidence that the 2014 meteor was indeed an interstellar object. The whisper became a quiet, profound revelation. Humanity had, for the first time, definitive proof that a rock from another star system had not just passed by our solar system, but had actually ended its journey here on our world. It was a moment of quiet connection, a realization that the vast gulf between the stars was not so empty after all. It could be crossed, and it had been. Let the wonder of this settle around you. Imagine that silent flash of light, unseen by human eyes, holding such an incredible secret. A secret that waited patiently for years in a column of numbers, until two curious minds uncovered its extraordinary tale. A tale of a journey's end and a new beginning for our understanding of the cosmos. The story of IM-1 did not end with its confirmation. For in science, a discovery is not an endpoint, but a doorway to a new set of questions. And the most tantalizing question of all was, could we find it? Could we retrieve a piece of this interstellar messenger from the ocean floor? The idea seemed almost impossible. To find fragments of a small object that burned up in the atmosphere and fell into the vast, deep ocean nearly a decade ago. It was a search for a cosmic needle in a planetary haystack. But for Avi Loeb, the lead astronomer, the possibility was too important to ignore. To hold a piece of material from another star system in our hands would be a monumental achievement for humanity. It would be like reading the page of a book from a library in a distant star city. And so a new chapter began, the Galileo Project. Named after the great astronomer who revolutionized our view of the cosmos by pointing a telescope to the sky, this project aimed to do the same by searching the depths of our own world. The mission was audacious. First, they had to pinpoint the landing site. Using the trajectory data from the fireball and incorporating wind and ocean current models, the scientific team narrowed down a search area on the seabed, a patch of the Pacific Ocean floor about 6 miles wide off the coast of Manus Island. Then came the expedition. A research vessel named the Silver Star was chartered, a sturdy ship that would become a floating laboratory and a home for the team of scientists, engineers, and crew who embarked on this remarkable quest. Imagine this ship,
sailing out onto the calm blue waters of the Pacific. The gentle, rhythmic rocking of the vessel, the endless horizon of sea and sky, the feeling of peaceful isolation on a mission of profound significance. The air is warm, the sun is bright, but the true object of their search lies a mile below them, in a world of cold, darkness, and immense pressure. To search this dark, silent world, the team designed a special tool. It was a large, flat sled, about the width of a small car, equipped with an array of powerful magnets. This was their deep-sea treasure hunter. They would lower this magnetic sled from the ship on a long, strong tether, letting it sink down through the water column, until it gently came to rest on the soft sediment of the ocean floor. Then the ship would begin to move, very slowly, methodically, towing the sled across the seabed like a lawnmower cutting grass. The process was slow, patient, and meditative. The quiet hum of the ship's engines, the gentle whir of the winch paying out and pulling in the cable, the watchful eyes of the scientists fixed on the monitors showing the sled's progress. For days they repeated this process. Line after methodical line, they swept the search area. The sled would be dragged for hours, then carefully hoisted back up from the depths, breaking the surface with a cascade of water. The team would gather around, their hearts filled with hopeful anticipation. They would carefully examine the magnets, cleaning off the dark volcanic sand and silt, searching for anything unusual, anything that shouldn't be there. They were looking for tiny metallic spheres, no bigger than a grain of sand. These are the telltale signs of a meteor that has burned up. As the rock vaporized in the atmosphere, tiny molten droplets would have cooled and solidified into these microscopic, perfect spheres, before falling into the sea. Imagine the profound patience required, the long hours spent watching a screen, the repetitive cycle of lowering and raising the sled. It is a testament to the human spirit of exploration, the gentle, persistent curiosity that drives us to seek answers. On that ship, rocking gently on the Pacific, the team was not just searching for rocks. They were listening for a whisper from the cosmos, a whisper they hoped to find captured in the silent mud of the ocean floor. And as you drift and relax, let the rhythmic image of this search soothe you.
The slow drag of the sled through the deep, quiet dark. The gentle rocking of the boat under a canopy of stars. A patient, hopeful search for a connection to the universe, unfolding in the most peaceful and remote of places. On that gently rocking ship in the middle of the Pacific, the team continued their patient work. They ran the magnetic sled across the designated area again and again. For many runs, they found nothing but the fine, dark sand of the ocean floor. But the spirit of discovery is a patient one. And then it happened. A moment of quiet, breathtaking success. As they cleaned the magnets from one of the sled runs, they began to see them. Tiny, almost invisible specks clinging to the metal, distinct from the surrounding silt. They brought out the microscopes, and there, under the focused beam of light, were the treasures they had sought. Perfect, minuscule metallic spheres, less than a millimeter in diameter. Imagine the feeling in that shipboard lab, the quiet awe, the sense of connection across an unimaginable void of space and time. In their hands, on a microscope slide, were objects that had likely traveled for millions of years from a completely different star system, only to end their journey here, to be found by a curious and determined team. They had found the needles in the haystack. Over the course of the expedition, they collected more than 50 of these tiny spherules from the targeted path of IM-1. But finding them was only the first step. The true story these microscopic visitors had to tell was locked within their chemical composition. The spheres were carefully transported back to laboratories at Harvard and other institutions for a painstaking analysis. Using state-of-the-art instruments called mass spectrometers, scientists could vaporize a tiny portion of a spherule and read its elemental signature, like a cosmic list of ingredients. This is where the story grows even more wondrous. As they analyzed the composition of these tiny spheres, they discovered something extraordinary.
The elemental makeup was unlike anything seen before in our solar system. Meteorites from our own asteroid belt have a very familiar pattern of elements. But these spherules were different. They had abundances of certain heavy elements that were hundreds of times higher than what is found in rocks from Earth, the Moon, Mars, or any known solar system asteroid. Specifically, they found a remarkable enrichment in beryllium, lanthanum, and uranium. The scientists nicknamed this unique signature B-Law for the chemical symbols of these elements. This B-Law composition was a stunning discovery. It was perhaps the strongest evidence yet that these spherules were not from around here. Beryllium is an element that is not easily produced in stars like our Sun. It suggested an origin story far different from that of our own solar system's material. The scientists began to wonder, what kind of celestial object could produce such a unique chemical fingerprint? The high concentration of these heavy elements, along with the incredible speed at which IM-1 hit our atmosphere, suggested that the material was also unusually strong, tougher than any stony or iron meteorite previously studied. The analysis pointed toward a fascinating possibility. This object, IM-1, was likely not just a simple rock from another star. Its unique chemistry suggested it came from a very specific place, the crust of a planet orbiting another star, a planet that was perhaps differentiated, meaning it had a heavy iron core and a lighter crust much like our own Earth. Perhaps this planet had oceans of magma. The B-Law signature might be a clue about the processes that happen on worlds utterly alien to our own. It's as if we received a postcard not just from another star system, but from a specific, exotic geological location within that system. Feel the quiet wonder of this. A tiny, perfect sphere, smaller than the head of a pin, holds a story of planetary formation around a distant, unknown sun. It's a whisper of cosmic history delivered to the bottom of our ocean. The analysis is like learning to read a new silent language. Each element a word, each abundance a part of the grammar, together telling a story of a place we may never see, but can now begin to understand, thanks to these microscopic messengers. The lab is quiet. The glow of the microscope is soft. And in that focused light, a connection is made. A bridge is built between our world and another, all within the beautiful geometry of a single tiny sphere. The discovery of IM-1's tiny spherules on the deep ocean floor was a profound moment. It confirmed that our Earth is not entirely separate from the wider galaxy, that we are touched by the cosmos in the most direct way imaginable. But IM-1, the messenger that completed its journey here, was not the only interstellar traveler to grace our solar system. It was simply the first one we identified.
In the years that followed its arrival, our watchful eyes, aided by ever more powerful telescopes, began to notice other visitors, fellow travelers on their own immense journeys. These visitors did not land on our world, but their silent passage through our celestial neighborhood broadened our perspective, revealing the variety and wonder of the galaxy's wanderers. Let us now gently widen our gaze from the microscopic world of the spherules and lift our eyes to the quiet darkness between the planets to witness the passage of these other guests. Our story shifts to the year 2017, to a peaceful mountaintop in Hawaii. Here, the Pan-STARRS telescope keeps its silent vigil. Night after night, its great eye opens to the sky, scanning the darkness, mapping the stars, and watching for anything that moves. Its primary mission is to find near-Earth asteroids, our solar system's local traffic. But on the night of October 19th, it detected something different. A faint, unassuming point of light moving with a speed and direction that made no sense. Astronomers around the world turned their telescopes toward this new object, tracking its path. And the more they watched, the more extraordinary its story became. Its trajectory was not the gentle, closed ellipse of a planet or an asteroid belonging to our Sun. It was a dramatic, open-ended hyperbola. It had swung into our solar system from a direction high above the plane where the planets orbit,
passed within the orbit of Mercury in a hairpin turn around the Sun, and was now heading back out, moving so fast that our Sun's gravity was powerless to hold it. This was, without a doubt, a visitor from interstellar space. It was the first large object ever seen passing through our solar system, and it was given a beautiful, fitting name from the Hawaiian language, Oumuamua. It means a messenger from afar arriving first. Oumuamua was a profound and deeply mysterious messenger. As astronomers studied the faint sunlight reflecting from its surface, they began to piece together a portrait of a truly unusual object. One of its most striking features was its shape. As Oumuamua moved, its brightness changed dramatically, dimming and brightening in a regular cycle. This told astronomers that the object was tumbling end over end. And the extreme variation in brightness suggested a shape unlike any asteroid or comet ever seen. It was not round. It was exceptionally elongated, perhaps 10 times longer than it was wide. Imagine, if you will, floating silently in the void of space. In the distance, against the backdrop of a billion unblinking stars, you see it. A dark, reddish object, tumbling slowly. It might look like a cosmic needle, a shard of rock, or a flattened, cigar-shaped sliver. It moves with a silent, graceful, and utterly alien motion. Its color suggested it was made of rock and perhaps metal, and that its surface had been irradiated by cosmic rays for millions, maybe billions of years, giving it a dark, ruddy coating. But here the mystery deepened. As Oumuamua made its closest approach to our Sun, where the heat and light are most intense, it behaved very strangely for a visitor from the cold depths of space. Usually, when a comet from the outer reaches of our own solar system gets close to the Sun, the ice on its surface vaporizes, creating a beautiful, glowing halo called a coma, and a long, streaming tail of gas and dust. But Oumuamua showed no such activity. Our most powerful telescopes looked for any hint of a coma or a tail, any sign of outgassing, and they found nothing. It was completely inert, like a dry, barren asteroid. This lack of activity was puzzling, but the greatest mystery was yet to come. As astronomers continued to track Oumuamua on its journey away from the Sun, they noticed something that sent a ripple of wonder through the scientific community. It was gently accelerating. It was moving away from the Sun slightly faster than gravity alone could explain. The push was tiny, a delicate and subtle deviation from its expected path, but it was unmistakably there. What could be giving this strange object a gentle extra push? For a comet, the answer would be simple: outgassing. The vaporizing ices would act like tiny natural rocket thrusters. But Oumuamua had no visible outgassing. So what was this invisible hand guiding it on its way? This quiet question opened a door to a universe of peaceful speculation. One idea was that Oumuamua was made of something we had never considered before, something exotic. Perhaps it was a nitrogen iceberg, a fragment chipped off a Pluto-like planet in another star system. Nitrogen ice would vaporize in the sunlight, but it might do so in a way that produced gas that was transparent and invisible to our telescopes. Or perhaps it was a cosmic dust bunny of sorts, an object so light and fluffy that the gentle pressure of sunlight itself was enough to push it along, like a solar sail.
The mystery of Oumuamua was a gift. It reminded us that the universe is not only stranger than we imagine, but stranger than we can imagine. It did not provide easy answers. Instead, it offered a profound sense of wonder. It was a silent traveler that tumbled through our home, broke all of our expectations, and then continued on its endless journey, leaving us with a beautiful and enduring puzzle. Its passage was a quiet reminder that the galaxy is filled with wonders we have not yet dreamed of. As you rest now, picture this solitary traveler. See it tumbling in the silent darkness, a reddish sliver against the stars, moving with a grace that defies our simple explanations. It is a symbol of the great, beautiful unknown, a gentle mystery that expands our sense of what is possible. For nearly 2 years, Oumuamua remained the sole example of a large interstellar visitor. Its strangeness led some to wonder if it was a complete anomaly, a one-of-a-kind object.
But then, in August of 2019, the story of our interstellar visitors took another turn. This time, the discovery was not made by a giant professional observatory, but by an amateur astronomer in Crimea named Gennady Borisov, using his own homemade telescope. While scanning the skies, he spotted a fuzzy object that was not on any of the star charts. He reported his finding, and soon, observatories all over the world turned their attention to it. The calculations were made, and they confirmed what Borisov suspected. This new object's path was also a wide open hyperbola. It too was a visitor from interstellar space. It was named 2I Borisov, the 2I signifying that it was the second interstellar object ever discovered. But as astronomers looked at Borisov, they saw something wonderfully different from Oumuamua. Where Oumuamua had been a sharp, inert point of light, Borisov was fuzzy and soft. It had a distinct glowing coma. And as it drew nearer to the sun, it began to unfurl a beautiful, faint tail. Borisov looked, for all the world, like a comet. It was behaving exactly as a comet should. If Oumuamua was the mysterious stranger that left us with more questions than answers, Borisov felt like a distant cousin, a traveler from a faraway land who nonetheless shared our family customs. The discovery of Borisov was profoundly comforting. It suggested that Oumuamua was not the only kind of interstellar traveler. It confirmed that objects familiar to us, like comets, are also cast out from other star systems and wander the galaxy. This meant that the processes that formed comets in our own solar system are likely not unique. Other stars, with their own families of planets, are also surrounded by icy debris in their outer reaches. The galaxy, it seemed, was full of cosmic snowballs, just like the ones we have here at home. Scientists eagerly studied the light coming from Borisov's coma to understand what it was made of. They found the chemical signatures of water and surprisingly high amounts of carbon monoxide. While the proportions were a bit different from typical comets in our solar system, the basic ingredients were the same. It was a tangible piece of evidence that the chemistry needed to build worlds, the simple molecules of water and carbon, are common throughout our galactic neighborhood. Borisov was a bridge. It connected our solar system to others, not through strangeness and mystery, but through a gentle, reassuring similarity. Imagine now these two visitors passing through our home one after the other. First, the silent, tumbling, reddish shard of Oumuamua, a profound enigma that defied classification. It challenged our assumptions and expanded our imagination. We watched it pass by in quiet awe, a fleeting glimpse of something truly alien. And then, 2 years later, comes Borisov, trailing its ethereal, ghostly tail like a ribbon of smoke in the solar wind. It glows with the soft light of vaporizing ice, a familiar sight that speaks of cosmic kinship. It reassures us that even across the unimaginable distances between the stars, some things are the same. And so, we have a trio of confirmed interstellar visitors, each telling a different part of a grander story. We have IM-1, the messenger that arrived and stayed, delivering a physical fragment of its home to the depths of our ocean, allowing us to analyze its unique, exotic chemistry in our laboratories. We have Oumuamua, the mysterious flyby, a cosmic puzzle that showed us the sheer diversity of objects that might be drifting in the interstellar darkness. And we have Borisov, the familiar comet, the reassuring traveler that told us we are not so different, that the building blocks of our home can be found orbiting other stars too. Together, they paint a beautiful and complementary picture. They confirm that our solar system is not an isolated island. We are part of a dynamic, interconnected galaxy. There is traffic between the stars.
A slow, patient, and mostly invisible migration of material has been happening for billions of years. These three visitors are simply the first ones we have been able to notice. They are the first whispers we have managed to overhear from a conversation that has been going on for eons. As you settle deeper into a state of rest, let the images of these three travelers drift gently through your mind. The tiny metallic sphere from IM-1, holding the secrets of an alien geology. The long, tumbling form of Oumuamua, a silent and graceful enigma. and the soft, glowing halo of Borisov, a comforting beacon of cosmic familiarity. Each one is a message. Each one is a thread connecting our small blue world to the vast and wondrous tapestry of the Milky Way. The arrival of these cosmic messengers, from the tangible fragments of IM-1 to the fleeting passages of Oumuamua and Borisov, does more than simply satisfy our curiosity. It gently shifts our perspective of our place in the universe. It opens a doorway in our minds to profound and peaceful ideas. If material from other star systems can travel here, what does that truly mean? What are the implications of living in such an interconnected galaxy? This realization is like discovering that the air we breathe contains not just the scents of our own world, but faint, ancient perfumes from 1,000 distant gardens. It leads us to ponder a beautiful and ancient idea, a concept known as panspermia. The word itself means seeds everywhere. It is the gentle hypothesis that the fundamental building blocks of life, the complex organic molecules that form the basis of all living things we know, might not have originated solely on Earth. Perhaps, the theory goes, these vital ingredients were forged in the dusty, gaseous clouds between the stars, or on other, older planets. And perhaps, just perhaps, they could travel from one star system to another, sheltered within the rocky embrace of a meteoroid. Imagine a distant solar system, billions of years ago. A planet, much like a young Earth, is struck by a large asteroid. The impact is powerful enough to eject rocks from the planet's surface into space, sending them on an outward journey, free from their home star's gravity. If that planet harbored primitive life, or even just the complex precursor molecules for life, some of them could be trapped within these ejected rocks. The rock would act as a tiny spaceship, its interior shielding these precious molecules from the harsh radiation of deep space. For millions of years, this natural vessel drifts through the cold and the dark. It is a dormant seed, a message in a bottle, cast into the cosmic ocean. Then, after its eons-long journey, its path happens to intersect with a young, developing planet in another star system, a world like our own early Earth. It streaks through the atmosphere as a meteor and lands as a meteorite, breaking apart and delivering its ancient, dormant cargo to a new and welcoming environment. This is the grand, poetic idea of panspermia. Not the journey of complex living creatures, but the gentle seeding of a galaxy with the potential for life. The discovery of interstellar objects like IM-1 makes this idea feel a little less like fiction and a little more like a tangible possibility. We now know for certain that the delivery mechanism exists. Rocks from other star systems do hit the Earth. We have found the fragments. And while the spherules of IM-1 were melted in their fiery entry, showing us only their elemental composition, it's not hard to imagine a larger interstellar meteorite, one whose core could remain cool and protected during its atmospheric passage. The journey is possible. The delivery is possible. This doesn't mean that life on Earth began this way, but it opens our minds to the beautiful thought that the spark of life may not be a series of isolated events, but a continuous, galactic process. It suggests that life, in its most basic form, could be a property of the cosmos itself, and that planets are simply the fertile gardens where these cosmic seeds can take root and blossom. It fosters a sense of belonging not just to a world, but to a living, breathing, interconnected galaxy. Beyond this profound question, these interstellar fragments offer us an incredible gift. They allow us to study the chemistry of alien solar systems without ever leaving our own. For all of human history, our study of the stars has been based on looking. We analyze the light that travels from them to us. From that light, we can deduce their temperature, their age, their composition. It is an amazing science, but it is like trying to understand a distant forest by only seeing its glow on the horizon. Now, with the spherules of IM-1, we have done something new. We have held a piece of the forest in our hands. The unique B-Lau signature of those tiny spheres is a direct measurement of the geology of a world formed around another star.
It's a message that tells us about the kinds of planets that might exist out there. It suggests that some of them might be even richer in certain heavy elements than the planets in our own solar system. Each future interstellar meteorite we find will be another page from this galactic encyclopedia, another clue to the diversity of worlds that populate the Milky Way. We are no longer just looking at the cosmos, we are beginning to touch it. This fosters a new feeling, a sense of being part of a vast galactic neighborhood. The stars at night begin to look less like distant, isolated points of light and more like neighboring suns, the campfires of a great cosmic community. And between these campfires, there is a constant, gentle exchange, an invisible rain of dust and rock, a slow conversation measured in millennia. Our planet, in its long life, has been breathing in this cosmic dust for 4.5 billion years. We are, in the most literal sense, made of stardust. And now we know that this stardust is not just from our own sun, but from countless other, older suns from across the city of the stars. Visualize the Milky Way now, not as a static band of light painted across the night sky, but as a living, swirling ecosystem. See the great clouds of gas where new stars are igniting. See the quiet, elderly stars breathing out their last layers of elements into the void. And see the countless tiny messengers, the meteoroids, drifting on the unseen currents of this galactic river. Some are carrying the basic elements forged in stellar cores. Some are carrying the chemical stories of distant rocky planets. And some, perhaps, are carrying the dormant seeds of life itself. We are on a shore of this river, and for the first time, we are beginning to notice the messages washing up at our feet. Let this thought soothe you into a state of deep peace, the feeling of being connected, the feeling of being home in a universe that is far more vibrant, interactive, and alive than we ever knew. The discoveries of IM-1, Oumuamua, and Borisov have opened our eyes and our minds. They are the first few words of a long and beautiful cosmic story that is just beginning to unfold. For centuries, we have looked up at the night sky and wondered. Now we are learning how to listen. This new era of awareness brings with it a calm and hopeful sense of anticipation. We know that these 3 visitors are not the last. They are simply the first ones we were able to notice with the tools we had. As our tools become more sensitive, our ability to listen for these whispers from the Milky Way will only grow. And so we look to the future, not with an impatient grasp for answers, but with a peaceful readiness to receive the messages that are already on their way. Our journey now takes us to a high, arid mountaintop in the Chilean Andes, a place called Cerro Pachón. Here, under some of the clearest, darkest skies on Earth, a new eye on the universe is taking shape. It is a marvel of gentle and patient observation, an observatory that will soon cast a wider net over the cosmos than ever before. This is the Vera C. Rubin Observatory. It is named after a pioneering astronomer who uncovered some of the most profound evidence for the existence of dark matter, the invisible scaffolding that holds our universe together. And just as its namesake revealed a hidden aspect of the cosmos, this observatory is poised to reveal the hidden traffic that flows between the stars. Imagine a silent, graceful structure, its large dome gleaming in the moonlight. As night falls, the dome opens, not like a narrow eye squinting at a single point, but like a great eyelid opening wide to take in a vast panorama. Inside, its telescope is a unique design. It has a huge mirror, more than 27 feet across, to gather faint, distant light. But its most remarkable feature is its camera. It is the largest digital camera ever built, a device of breathtaking sensitivity with a field of view that is immense. In a single snapshot, it can capture an area of the sky 40 times larger than the full moon. The Rubin Observatory's mission is one of patient, rhythmic repetition. It will not stare at one small patch of sky for a long time. Instead, every few nights, it will gently and systematically scan the entire visible southern sky. Click. A snapshot of one vast star field. The telescope moves silently. Click. Another snapshot of the next.
On and on it will go, painting a complete picture of the heavens, and then, a few nights later, it will begin again, painting a new one. Over the course of 10 years, it will assemble these images into a colossal time-lapse movie of the universe, a deep, detailed, and dynamic map, chronicling a decade of cosmic life. It is this unique ability to see wide and to see often that makes it the perfect tool for finding interstellar visitors. Oumuamua and Borisov were faint and they were moving fast. We were lucky to spot them.
But the Rubin Observatory is designed to catch exactly these kinds of faint, fast-moving objects. As it compares each new picture of the sky with the one taken a few nights before, its powerful computers will be programmed to notice anything that has moved or changed in brightness. It will flag every tiny new point of light that appears where none was before. Most of these will be asteroids from our own solar system, and that is important work in its own right. But among them, inevitably, there will be some whose speed and trajectory mark them as outsiders. The observatory's software will be like a gentle sieve, sorting through the river of data and catching these rare interstellar gems. We will no longer find just one interstellar visitor every couple of years. The Vera C. Rubin Observatory is expected to find dozens, perhaps even hundreds of them. We will begin to see the true diversity of this galactic traffic. We will find more objects like Oumuamua, and we can study them as a population to understand if its strange, elongated shape is common or rare. We will find many more comets like Borisov, and by analyzing their chemical composition, we can start to build a map of the different chemical environments around other stars. We might even find types of interstellar objects we have never imagined, new categories of travelers with their own unique stories to tell. The sky will no longer be a static backdrop, but a place of constant comings and goings, a celestial harbor with ships arriving from 1,000 distant ports. And what about the smaller messengers, the ones like IM-1 that actually enter our atmosphere? The Rubin Observatory will help us find those as well. By tracking the paths of incoming objects with incredible precision, it will be able to predict which ones are on a collision course with Earth. And by measuring their velocity before they enter the atmosphere, it can tell us which ones are interstellar. This will transform the search for interstellar meteorites. Instead of searching the ocean floor years after a chance event, we could have advance notice. We could know with great accuracy when and where an interstellar meteor is going to land. Imagine receiving a cosmic weather forecast. An interstellar object, half a meter in diameter, is expected to land in this particular desert or on this specific ice sheet at this time. Expeditions could be ready. We could be there to recover the fragments soon after they arrive, fresh, pristine messengers ready to share their secrets. The ongoing search for these cosmic whispers is not limited to giant new observatories. It is also about listening more carefully with the tools we already have. The network of sensors that first detected the fireball of IM-1 is always watching. Scientists are now developing new ways to analyze that data, creating more refined techniques to pick out the telltale signature of high-velocity interstellar impacts. They're planning for a dedicated, global network of skywatching cameras, a system designed specifically for science to track these meteors with even greater precision. It is like we are slowly building a global hearing aid, tuning it to the specific frequency of these arrivals from afar. Each new sensor, each improved algorithm makes our hearing a little sharper. The Galileo project, too, looks to the future with a calm sense of purpose. The first expedition to the Pacific was a proof of concept. It showed that this seemingly impossible search could succeed. Now they plan to return. They will conduct a more extensive search of the area, hoping to find larger fragments of IM-1, pieces that might have been protected from the intense heat of atmospheric entry, pieces that might hold even more profound secrets within their core. And they are already looking at data for other potential interstellar meteor events, like a second object, nicknamed IM-2, which streaked across the sky over Portugal in 2017. Perhaps future expeditions will sail to other oceans or trek across remote landscapes, following the trail of these newly identified messengers. This ongoing search is a beautiful form of cosmic listening.
It requires the same qualities as deep meditation: patience, stillness, and a gentle, open awareness. We are not shouting questions into the void. We are simply quieting ourselves and refining our senses so that we can better hear the answers that are already whispering all around us. The universe is constantly communicating, not in words, but in the language of light, of gravity, of chemistry. The passage of a comet, the glow of a distant nebula, the composition of a microscopic spherule. These are all parts of the ongoing story. Our task is to become better listeners. So, let your mind drift now to that peaceful mountaintop in Chile. Imagine the silent, graceful movement of the giant telescope dome as it opens to the cool night air. The stars emerge, a brilliant, silent chorus.
There is no sound but the gentle breeze and the quiet hum of machinery, the sound of data flowing. A new picture of our universe is being painted, pixel by pixel. In that flow of information, new discoveries are sleeping, waiting for the right moment to awaken. Feel the sense of peaceful anticipation, the calm optimism that comes from knowing that our understanding is always, gently, expanding. We are at the beginning of a new conversation with the cosmos. We have learned a few of the words, and we are patiently waiting for the next sentences to arrive. We are listening for future whispers, confident that the universe has many more wonderful stories to tell. As our journey through the cosmos begins to draw to a close, let your awareness travel back from the distant stars, back from the silent mountaintops, back from the deep and quiet ocean floor. Bring your focus gently back to the simple, peaceful reality of this present moment. The feeling of the surface beneath you supporting you completely. The soft weight of your blanket, a gentle anchor to this calm and quiet space. The rhythmic, effortless flow of your own breath, a steady, soothing presence that has been with you all along. Tonight, we began with a simple question, a whisper on the edge of sleep. Has our world been touched by visitors from other stars? We have traveled far to find the answer. We journeyed through the language of meteors, learning to distinguish a local traveler from a true interstellar messenger. We stood on the shores of the Pacific and witnessed the silent, fiery arrival of IM-1, a tiny visitor that carried a story millions of years old. We sailed on a calm sea and descended into the deep, dark silence of the ocean floor, joining the patient search for a cosmic needle in a planetary haystack. And we peered through the lens of a microscope into the heart of a tiny, perfect sphere, and found a chemical signature unlike anything from our own solar system, a tangible message from an unknown world. Our journey confirmed that the answer to our question is a quiet and resounding yes. Our world has been touched. We are not isolated. We are part of a grand, interconnected galaxy that exchanges materials, stories, and perhaps even potential over the vastness of time and space. We have felt the profound connection that comes from this realization, the feeling that the ground beneath us is composed of dust from countless suns, the feeling that we belong to a vast galactic neighborhood whose quiet messages are only now beginning to be read. So now, as you prepare for a deep and peaceful sleep, hold this feeling of connection in your heart. Let it be a source of comfort and wonder. Visualize our Earth, your home, turning silently in the velvet darkness. See it as a beautiful blue and white marble cradled in the vast starry expanse of the Milky Way. And imagine, all around, a slow, gentle, and invisible rain. A constant shower of microscopic dust, particles from comets, from asteroids, and yes, from other star systems far, far away. This stardust, carrying whispers from distant suns, settles gently on the mountains, on the forests, on the oceans, and on the roof of the very room in which you lie. You are breathing in the cosmos. You are part of its endless, beautiful story. There is nothing left to do now but rest. Let go of all your thoughts and allow yourself to drift on the quiet currents of the night. The universe is vast, but you are safely held within it. The mysteries are deep, but you can rest in the quiet wonder of it all. Sleep now, friend.
Sleep deeply, and may your dreams be filled with the quiet beauty of a billion silent shining stars. Sleep well. As our journey through the cosmos begins to draw to a close, let your awareness travel back from the distant stars, back from the silent mountaintops, back from the deep and quiet ocean floor. Bring your focus gently back to the simple, peaceful reality of this present moment. The feeling of the surface beneath you, supporting you completely. The soft weight of your blanket, a gentle anchor to this calm and quiet space. The rhythmic, effortless flow of your own breath, a steady, soothing presence that has been with you all along. Tonight, we began with a simple question, a whisper on the edge of sleep. Has our world been touched by visitors from other stars? We have traveled far to find the answer. We journeyed through the language of meteors, learning to distinguish a local traveler from a true interstellar messenger. We stood on the shores of the Pacific and witnessed the silent, fiery arrival of IM-1, a tiny visitor that carried a story millions of years old. We sailed on a calm sea and descended into the deep, dark silence of the ocean floor, joining the patient search for a cosmic needle in a planetary haystack. And we peered through the lens of a microscope into the heart of a tiny, perfect sphere and found a chemical signature unlike anything from our own solar system, a tangible message from an unknown world. Our journey confirmed that the answer to our question is a quiet and resounding yes. Our world has been touched. We are not isolated. We are part of a grand, interconnected galaxy that exchanges materials, stories, and perhaps even potential over the vastness of time and space. We have felt the profound connection that comes from this realization, the feeling that the ground beneath us is composed of dust from countless suns, the feeling that we belong to a vast galactic neighborhood whose quiet messages are only now beginning to be read. So now, as you prepare for a deep and peaceful sleep, hold this feeling of connection in your heart. Let it be a source of comfort and wonder. Visualize our Earth, your home, turning silently in the velvet darkness. See it as a beautiful blue and white marble, cradled in the vast starry expanse of the Milky Way. And imagine, all around, a slow, gentle, and invisible rain. A constant shower of microscopic dust, particles from comets, from asteroids, and yes, from other star systems far, far away. This stardust, carrying whispers from distant suns, settles gently on the mountains, on the forests, on the oceans, and on the roof of the very room in which you lie. You are breathing in the cosmos. You are part of its endless, beautiful story. There is nothing left to do now but rest. Let go of all your thoughts and allow yourself to drift on the quiet currents of the night. The universe is vast, but you are safely held within it. The mysteries are deep, but you can rest in the quiet wonder of it all. Sleep now, friend. Sleep deeply, and may your dreams be filled with the quiet beauty of a billion silent shining stars. Sleep well.
And we peered through the lens of a microscope into the heart of a tiny, perfect sphere and found a chemical signature unlike anything from our own solar system, a tangible message from an unknown world. Our journey confirmed that the answer to our question is a quiet and resounding yes. Our world has been touched. We are not isolated. We are part of a grand, interconnected galaxy that exchanges materials, stories, and perhaps even potential over the vastness of time and space. We have felt the profound connection that comes from this realization, the feeling that the ground beneath us is composed of dust from countless suns, the feeling that we belong to a vast galactic neighborhood whose quiet messages are only now beginning to be read. So now, as you prepare for a deep and peaceful sleep, hold this feeling of connection in your heart. Let it be a source of comfort and wonder. Visualize our Earth, your home, turning silently in the velvet darkness. See it as a beautiful blue and white marble, cradled in the vast, starry expanse of the Milky Way. And imagine, all around, a slow, gentle, and invisible rain. A constant shower of microscopic dust, of particles from comets, from asteroids, and, yes, from other star systems far, far away. This stardust, carrying whispers from distant suns, settles gently on the mountains, on the forests, on the oceans, and on the roof of the very room in which you lie. You are breathing in the cosmos. You are part of its endless, beautiful story. There is nothing left to do now but rest. Let go of all your thoughts and allow yourself to drift on the quiet currents of the night. The universe is vast, but you are safely held within it. The mysteries are deep, but you can rest in the quiet wonder of it all. The pace of your breath slows and softens. Each breath out is a release, letting go, drifting down. The world outside fades away, leaving only this peace, this quiet, this connection to the silent, turning stars. Feel the gentle pull of sleep, a soft, gravitational tide drawing you into a state of deep and dreamless rest. Your body is heavy, your mind is still. You are floating now in a calm, dark, and peaceful sea, the sea of sleep. There is only the gentle rhythm of your breathing, in and out. A soft and steady pulse, like the quiet turning of the earth. The stars are watching over you, the Milky Way is your blanket, and all is well. Rest now. Rest in the knowledge that you are stardust, a child of the cosmos, home among the stars. Sleep now, friend. Sleep deeply. And may your dreams be filled with the quiet beauty of a billion silent, shining stars. Sleep well. Sleep now.